This is our question for today from LeetCode, that is smallest palindromic rearrangement 1. You are given with a palindromic string yes, written the lexicographical smallest palindromic permutation of yes. So the first example where our string yes is equal to z, only a single character. That means the palindrome is the same string itself. So we return the same string if only one character is given. But if we have a string with many characters like this, then we need to think and then we need to return the smallest palindromic. See, B is there, but A is smaller than B, right? Because see, in alphabetical order, A comes first and B comes next. That is how we determine if alphabet is smaller or not. So this is what the example says. Now let's try to visualize this question so that we come up with a good solution. So if we take this as our question, let me take a laser pointer. Okay. First of all, we need to count the frequency, which we will be doing with the help of array with the name frequency. Okay, these are the character and these are the frequency of the character. Firstly, we'll build the answer string from the left half. Okay, so build the left half. Take the half of every frequency. So these are our characters present in the yes string, and when you divide the frequency with 2, you get 1. So copy each of them into the left in the order C, A, C, D. And then we need to find the middle. Middle is how do you find the middle character? That is when the frequency of any element is odd, then there you'll get the middle element. But in this case, we don't have a odd frequency. So we have even frequency throughout all the elements given in the string. So we calculate the left half of the string that we have to written, and then there's no middle character. Mirror the left side. That means we have to reverse the left that we have obtained. So this will become the right. And then we have to add left plus right to get our final answer. This is the smallest string that we will be written. Now let's look at the same thing for our odd length. This is the odd length. Here the frequency of A is 2 and frequency of B is 3. We construct left. Left is all the even things. So one A will be there, one B will be there. And then in the middle, we'll have one of the element from B, because B is odd, right? That will come in the middle. And then we have to reverse the left to get the right. This is how. This is the right. And then we add left, middle, and right to get our final answer. So our overall flow will look like this. Get the input string, count the frequency, build the left half, then find the odd frequency. If there is odd frequency in the calculated frequency, then that character will be added to the middle, and then we add left, middle, and the right to get the smallest palindrome. Okay, now let's start coding. First of all, we need to create the frequency array of size 26. Let's start coding. Firstly, we will build a frequency array. Let's name it as freq new int of 26. Then we need to traverse through each and every character of yes string. Traverse through the string and count every character. Int, no, it's character, right? Char C from yes dot to char array. This is the function used to convert each and every character of the string yes into character array. Then we need to calculate the frequency using this. So here ch, which c, which is the character, minus character a, will give us I plus plus, frequency plus plus. This will give us the frequency. How is this? If it's a and a, then the answer will be 0, right? In frequency of 0, you'll have all the frequency of a character. That's how. We have 26 characters in small letters. So each index, that is from 0 to 25, you'll have the frequency of that mapping characters. Moving on to the next, in our algorithm part, we have traversed characters from A to Z. This we did, and then we need to append frequency by 2 copies of each character to the left half. For this, we'll need a string builder. We'll name it as left is equal to new string builder. Okay, then we'll have to name a character called middle, which we will assign it to be 0, because in case of even, it has to be 0. We need not add anything to the middle. Now we will have to traverse through each and every character through their index, and this is how we do it. Less than 26 I plus plus. Then char ch is equal to char. This is where we are converting, typecasting our result into character. Through this statement, we are calculating the character at ith position. So this, you can see, a plus I, this will return an integer, which we are converting to character based on the ASCII. Okay. I hope you got it. Based on ASCII, we are converting into character. And now this has to be appended to our string left how many times. That will be calculated using this for loop, which starts from 0, j less than frequency of I divided by 2, and then j plus plus, then left dot append ch. Okay. Now if frequency of I mod 2, if it's not even, then it will written as 1, right? Then you have to add middle is equal to ch. Okay. Next, we have to initialize one more string builder called answer. Okay, but we are supposed to return string that we can convert to string, but we will initialize a string builder called ans, new string builder, and then we need to check if middle is not equal to 0, then ans dot append middle. If it's equal to 0, then we need not append it. That is ans dot append new string builder left dot reverse Okay. This is adding the rightmost elements to our answer. And then we'll be returning that into our answer. Okay. Now written answer. Okay. And then where did we miss? That's it, right? String builder left. Written ans dot toString. This is what we forgot. ToString. It's a function. String builder. Oh, B should be capital here. Oh my god, the left thing is missing. We didn't add the left thing. Let's do it. Ans dot append left. Then add the middle if it's present. Then add the reverse. That's right. Then written answer. Now it should work. Okay. Yes. Now let's talk about the complexity. Firstly, let's move to time complexity. So in time complexity, we have to count the characters. And here we move across n elements once. So the time complexity is big O of n. And then we need to build the left half of the palindrome. Building of the palindrome also takes time complexity of big O of n. So overall, including both of them, we have our final time complexity to be big O of n. Then let's go to the space complexity. The frequency array, where it contains 26 characters, which is like constant, right? The space complexity is big O of 1. And the left half, the answer, reversed half, all of them take the space of big O of n. So overall, including all these cases, conditions, we get the space complexity to be big O of n. Thank you.